Hi, my name is Isaac, and the subject that I teach is AP Physics. My experience in this subject goes all the way back to high school, where in the tutoring center, I taught AP Physics, Calculus, and AP Chemistry. In addition to that, I have taught in the Kennedy Center for the Disabled, and I have taught underprivileged children, math, science, and English. I am currently a third-year student at McGill studying electrical engineering, and some of my specialities in that field include circuit analysis and design, discrete circuits in a laboratory environment, and I have also studied high-level electromagnetics. Another subject that I teach is AP Computer Science. I am currently pursuing a specialization in computer architecture and digital systems design. Some of the individual projects that I've also done in computer science are creating a web search engine and programming an autonomous soccer-playing robot. Some of these projects I have completed with the tools that are taught in AP Computer Science, which is what makes me believe that I would be one of the best people to deliver the topic. Hi, so the concept I'm going to teach today is Kirchhoff's current law and Kirchhoff's voltage law, two fundamental laws in electrical engineering and physics that will take you all the way up to the graduate school level. So the two main concepts behind Kirchhoff's current law and Kirchhoff's voltage law is the conservation of charge and conservation of energy. But before we get into that, I would like to introduce a bit of recap. So first, Ohm's law, right here, V equals IR, and the definition of a current, I equals Q over T. And the third law isn't really much of a law, but much more of a concept, wherein voltage is somewhat related to current, in that you can't increase voltage without adding energy, or decrease voltage without taking out energy. So, to get into a bit of an example, we have KCL right here. What KCL says is that any charge that enters a node must have equivalent charge leaving it, hence conservation of charge. As you see here, the current of IA enters the node on the top right over there, and current IB and IC leave that node. So what we can say is that IA equals IB plus IC. And this is the definition of Kirchhoff's current law. All the current that enters any one node, wherein a node is the intersection of several wires, must equal the amount of current that is leaving that node. Now, Kirchhoff's voltage law is a little different in that sense. Conservation of energy. So what it says is that any voltage that is gained in a loop must also be lost within that loop. So right here we have a voltage gain by the independent voltage source, then the two resistors which create a voltage loss. And what we can say is that the voltage gained will equal the voltage lost, such that Vs would equal I times R1 plus I times R2. Now, I'd like to do a quick example to illustrate this concept. What we use in Kirchhoff's voltage law and Kirchhoff's current law a lot is to analyze circuits and to find where the currents in tough areas or the voltages across resistors that are in very obscure locations. Actually, in higher level physics and higher level engineering, what we can see is that we can actually use computer programs to analyze circuits using these two methods. And that, of course, saves us a lot of time because we don't have to do it by hand. So, first, I'd like you to consider this circuit right up here. This circuit right here, and I'm asking you, and the question asks you to find the current right there, up here, I. So normally, what you'd have to do with the methods you have already learned is that you'd have to first add up the two resistors in parallel, this one up here and this one down here, and then add it to the series and this one over here, figure out the current throughout this circuit, and then use a current divider to find the current over here, which may prove to be somewhat of an inefficient method. So instead, what we're going to use is Kirchhoff's current law. So if you remember, we looked at a node that was very similar to this one. And what we can say is that all the current going in will equal all the current going out. So for starters, let's consider this top node up here, and let's call it V. We don't know what V is, we don't know what the voltage at V is, but of course there's going to be a voltage here. And let's assume what's down here is ground, or 0. So if we look at basic circuit analysis, what we can say is V minus Vs over R1 plus V over R2 plus V over R3 would equal 0, as we can see right here. And I'll explain each term individually. V minus Vs is the voltage across R1. V minus I1, or I1 in terms of I2, and then substitute it back into another equation, eventually leading to two current answers, and also, of course, I2, which would yield to a final answer over here. Well, thank you very much for listening to my short introduction of Kirchhoff's current law and Kirchhoff's voltage law. I hope you have learned something today, as this is a very important concept that if you choose to go into physics and electrical engineering, you will find that it takes you a long way. Thank you very much.